So they're hand in hand, right? Solving exponential equations requires logarithms. Solving logarithmic equations requires exponents, right? Because what's the main thing I want you to remember? Well, there's a lot of things. I want you to remember everything. One of the big things I want you to remember is that logarithms, exponentials, they're inverse functions of each other, right? So it's like saying you can't solve an addition equation unless you know subtraction, because you have to undo the addition. So when we solve exponential equations, we need to use logarithms, the inverse. When we solve logarithmic equations, we need exponents, the inverse. Okay? So they're both connected, which is why they're in one section. We're going to start with the log equations today. Okay? So you've already done, by the way, more than half of this section. If your life depended on it, many of you could do almost all of this homework assignment already. Okay? You might not be happy about it, but you could. So some of this stuff should be familiar, and some of this stuff will be things that you've forgotten, which is okay, right? As much as nobody likes to admit it, it is okay to forget mathematics. It happens pretty frequently. I myself have forgotten so much math, but you remember it once you study it again. Okay, so here we go. Solve. This is example 1. Solve the following. Part A. Log base 2 of x plus 3 equals a negative 1. And you might look at this and say, whoa, this looks terrible. I guarantee you guys, if I tell you the first step, you could solve it like that. Okay? I'm curious whether anyone knows the first step. Okay? Because we've done it before. And I'm not going to wait unless anyone's feeling super chatty. But all we're going to do is just get rid of the logarithms. Okay? We have logarithms. I don't want to work with logarithms. We've done this before. Okay? Isolate the log. Then put in exponential form. Okay? No, don't do that. But I appreciate your willingness to say something. But don't do that. Nope. Isolate the logarithm. So logarithm here is already isolated. Now we want to put this in exponential form. Okay? By isolate, I mean the only thing on the left-hand side of this equation is a logarithm, which is good. Okay? Now we put it in exponential form. Remember, the base of the logarithm becomes the base of the exponential. The exponent is that right-hand side. So this is the same thing as what we just wrote above. Okay? These are the same thing. This is the definition. This is what a logarithm means. Okay? If you're ever sitting there having an existential crisis, who am I? What am I doing? Just imagine yourself as a logarithm. Logarithms don't have existential crisis. Logarithms know exactly what they are. They're exponential equations. Okay? These two things are the same thing. So, and now we're almost done, right? This is just a linear equation, right? 2 to the negative 1, that's just 1/2. Well, how do I solve 1/2 equals x plus 3? Lexi's going to save her life by being able to solve this. Lexi, how do you solve this equation? Lexi says, you just subtract 3 from both sides, Jason, and Lexi would be right and she wouldn't be dead, which is nice. Okay, so subtract 3 from both sides. And what do we get? We get x is negative 2.5. We did it. Let's check our answer. Right, you can always check your answer if you're solving an equation. If I plug this in, does it work? What is the log base 2 of negative 2.5 plus 3? Well, that's the log base 2 of just 1/2. And let's say hypothetically you forgot how to do this. Remember the change of base formula says we could turn this into the natural log of 1/2 divided by the natural log of 2. That's what the change of base formula says, right? That we can turn any logarithm into a ratio of logarithms. We can use the natural log, we can use the common log, we can use log base 2222, any base we want, and we can type this into our calculator. So let's see what it is. Let's go over here, type it into our calculator, pretend this is a calculator. What is the natural log of 1/2 divided by the natural log of 2? Oh, it's -1, which is exactly what we wanted, right? We wanted this logarithm to equal -1. So we know our answer is correct. Why does the 2 turn into a half? So it's the -2.5 plus 3. This becomes 1/2. The 2, oh, this, yeah, so this exponent is really far away, but it's 2 to the -1st power. Sorry, Gabe. This is an exponent right here. It looks like it's flying away, but it's attached. 2 to the -1st power is going to be 1/2. Thank you for asking. Okay, so we solve the equation. Isolate the logarithm, then put it in exponential form. The logarithm's already isolated. Here's exponential form. Then we just solve the equation. You can also check your answer. Excuse me, please underline. Thank you. So to check our answer, we plugged in our answer to the left-hand side and said, well, hey, look, that equals the right-hand side. Neato. And this is essentially everything you need for today. Essentially. But you guys know how it works, right? We do a part A, and then it just gets a little bit more complicated after that. It's okay, Lexi. You have plenty of opportunities to redeem yourself. Not that I think you need redemption. But if you're worried about the math mafia, let's do part B. 2 ln x plus 3 equals 7. What are we supposed to do? Remember, isolate the log and put in exponential form. So, Lexi. No, all right, Lexi died. Or didn't die, depending on who you believe. Delaney, now it's your life on the line. Delaney, what's the first step for this example? This is your hint. Okay, Delaney's dead too. Oh no. All right, we need to isolate the logarithm first. Okay. So subtract 3 from both sides. We have 2 ln x equals 4. And divide both sides by 2. To get that natural log of... Whoa. Natural log of x equals 4 divided by 2, which is 2. And now, Delaney, what do we do next? Delaney Bowers says, put it in exponential form, LOL. You're correct. Good. Good. So to put this in exponential form, remember this is log base e. This is just shorthand. Natural log is just log base e. So the base of the logarithm is the base of the exponential. The right-hand side is the exponent. This is going to equal x. Is Lane here? Lane, do you want to see whether you live or die today? This is our answer, by the way. E squared can't really be simplified. It can be approximated with a calculator. This is the exact answer. And again, we could check our answer. Let's say we wanted to check. Left-hand side is 2 times the ln of e squared plus 3. Type that into a calculator. What does it look like? 2 times the natural log of e squared plus 3. Calculator says that's 7. Neat. Good. So I imagine this is like one of those movies where everyone's like taken captive by the bad guys. The bad guys ask Lexi a question. She answers wrong. They go to Delaney. Hey, Delaney, what do we do with this next problem? Delaney answers. Lane's up next. Watch out. Okay. Part C. How do we solve this equation? 2 times the natural log of 6x equals 7. Lane, what's the first step? That's not a good answer. Your life depended on this. You wouldn't say oof. Oh no. All right. Isolate the logarithm, then put it in exponential form. I'm killing off my whole class. I'm the George R.R. Martin of math class. Well, at least I'm not turning it into a show because we're nearing the last season and we don't like what happened in the last season of that show. All right. Well, looks like Lane is refusing to put his life on the line here. We're going to divide both sides by 2, right? We need the natural log to be isolated. There's a times 2 in front. That's no good. Divide both sides by 2. You get natural log of 6x equals 7 halves. Now that the logarithm is isolated, we can put it in exponential form. Okay. Remember again, this is log base e. So the base of the logarithm becomes the base of the exponential. And then the right-hand side becomes our exponent. And the 6x is over here. See, that's the kind of sentence, Lexi, that I laugh at and then think, what happens if someone just sends that sentence to like the division chair or like the dean? Hey, how's your math class going, Lexi? Well, it's kind of like the show Power, but instead of drug dealers, we have a math teacher that's killing us. Oh, great. What class are you in? All right. And then we're almost done, right? We need to solve for x. So we divide both sides by 6. So x is equal to 1/6. E to the 7 halves. Can't be simplified. This is our exact answer. You could approximate it. But usually we only approximate for applications in a math class. Okay. All right, Gabe. You feeling up for part D? Actually, part D is kind of hard. Part D is something different. We won't make Gabe derive part D. Okay. There's kind of multiple ways of doing part D as well. Okay. Actually, we'll do a bonus. We'll do a bonus question for Gabe. And then we'll move on to new stuff. After we see whether Gabe is our sole survivor. All right. How about 2 natural log of x plus 1 equals 10? What's the first step, Gabe? Isolate, yeah, but what does that mean? You're good so far. Divide by 2. Saved by Ashley. Good work. to get the natural log of x plus 1 equals 5. What do we get next? Anybody. This is no time to be selfish. We'll all help Gabe out here. All right. What do we get in the next step? Can Gabe's life be saved? Can we save at least one person's life? You can help from beyond the grave, Lexi. This is a supernatural episode. E to the 5th. Oh my word, Lane comes back from the dead. We transform this into an exponential equation. We get e to the 5th equals x plus 1. And then we just subtract 1 from both sides. Good, Gabby. Good, Gabe. Man, you guys are on top of this. I told you guys. So we just subtract 1 from both sides. E to the 5th minus 1 is our final answer. Okay. Good stuff. Okay, so that's one kind of logarithmic equation. All right. There's some other ones that can be, they're sort of more complicated, but sort of easier depending on your point of view. Okay. So let's look at another one with part E. The natural log of x squared equals the natural log of 2x plus 3. So there's two ways to do this. If you really want to be consistent, we isolate the natural log. There's two natural logs. How can we isolate something when there's two of them? Well, there's two answers. One, we could just, they're already isolated on, right? Each one's isolated on one side. Or we could combine them into one logarithm. We could subtract this logarithm over, and then we have subtraction. We can combine logarithms through subtraction. Okay, so two ways. Also, since natural log is a one-to-one function, if two natural logs are equal to each other, okay, if two natural logs are equal to each other, because they're one-to-one, their insides have to be equal. So we can just jump straight to this. If two natural logs are equal to each other, their insides must be equal. But it's only if, this is only if we have the natural log of something equals the natural log of something else. If there's other stuff, then you can't do this. So watch out. Okay. So now we just have to solve this equation. And hot dog, what kind of an equation is this? We had a logarithmic equation, and now we got our very own favorite kind of equation, a quadratic equation. We can factor, we can use the quadratic formula, we can complete the square. Whoa! Okay? So let's try to factor this. X squared minus 2x minus 3 equals 0. All right. We're going to get two answers here. X minus 3 and x plus 1. X is equal to 3 and negative 1. You say, oh boy. But you have to be very careful when you're solving logarithmic equations this way. You have to be very careful that it's still in the domain of log, right? We can't take the logarithm of a natural number. So if our answer were like negative 20, that would cause us to take a log of a negative number, and negative 20 could not be an answer. So you are going to have to watch out for little sneakers. And I'm not talking about the shoes. You're going to have to watch out for sneaky little answers in this section. So it's a good idea to get in the habit of checking your answers. So 3 and negative 1. Let's check those over here because I don't have room. Right? If it's 3, is the natural log of 3 squared equal to the natural log of, why is that parenthesis over there? 2 times 3 plus 3. Check that. It will, right? Natural log of 9 equals the natural log of 9. We're good. Check the other one. Is the natural log of negative 1 squared equal to the natural log of 2 times negative 1 plus 3? Well, that's the natural log of positive 1. Is that natural log of positive 1, which is 0, by the way, is that equal to the natural log of positive 1? Yeah. So use your calculator to check these. Okay. So we checked our answers. They both check out. No problems here in part E. But there might be a problem in part F. We will see. Okay. Part F. F is in frantic. Frantically fighting for your life through mathematics. Okay. Common log of 4 plus the common log of negative 5x equals 2. F is in failing. No. That's no good. Sorry, I'm getting excited. I'm going a little fast. So, next up, we're going to solve another equation that does not fit. Okay. In part F, we have two logarithms again, but we can't just get rid of the logs, right? You can only get rid of the logs if you have two logs equal to each other. But there's a 2 that's just hanging on over here. That's not going to allow us to do this the same way. So we're going to need to solve this the way we solved the earlier ones. We need to get only one logarithm. Well, we have two logarithms. How do we turn two logarithms that are connected by addition into one logarithm? We have a property for that. Okay, and properties of logarithms will be on your quiz today. So you need to know for your quiz how to combine this left-hand side. And we will also be using this to solve this equation. Okay, so the left-hand side becomes the log of something, and the right-hand side's 2. You multiply the insides. Good, Lexi's back from the dead too. Excellent, I'm glad we have some necromancers here or something. So you multiply 4 and negative 5x to become negative 20x. And again, your breathing might start to get heavy. Your heart might start thumping fast. Jason, you said we can't take the logarithm of a negative number. You're right, Jason. We can't take the log of a negative number. But we don't know that this inside is negative, right? It looks like a negative number, but it might not be a negative number, right? If x is negative 1, the inside is positive 20. Okay? So even though it looks negative, it might not be negative because we don't know what x is. Okay? So, again, remember, what is the common log? Common log is log base 10. So when you turn this into an exponential equation, this becomes 10. The base of the logarithm becomes the base of our exponential. 10 squared equals that inside, negative 20x. All right, I'm assuming people are good with the previous one. I will try not to go at lightning speeds today. But if I get carried away, just please tell me to go back again. So everyone knows how to solve this equation. Right, this is just 100. 10 squared. All you got to do to solve for the x, divide by that negative 20. Okie dokie. So we divide by negative 20. And we get that x equals negative 5. And again, the thump, the thump, the thump, the thump. Your heart is thumping. Good, Delaney. You're alive again too. This is like a. Oh, never mind. Negative number. Negative numbers are no good for logs. We can't take the log of a negative number. Let's slow down. Let's check our answer. See if this is a real answer or not. okay, is the log of 4 plus the log of negative 5, right? Negative 5 times negative 5. Is that equal to 2? Well, if you want to be a superstar, you can do this by hand, or you can just use a calculator. If you use a calculator and type that in, you're going to get that it's equal to 2. So because it checks out, we know we have the answer. Okay. Last logarithm problem is going to be part G, and then we're going to do some of the exponentials. Okay. We probably won't have much time for reviewing today, because I really want to finish this on Friday without having another 75-minute lecture. I'll try to incorporate review into this, like when I mentioned the change of base formula and we're talking about properties of logs. Let's do part G. G as in good gravy. This problem is fun. The natural log of x minus the natural log of x plus 3 equals the natural log of 6. Remember what I said before. If one natural log equals another natural log, then their insides have to be the same. But this, right, this is not one natural log. This is 2 logs, not 1. If this were only 1 log, and we had a log equal a log, their insides would be the same. Well, it's unlucky. Unfortunate. Let's go home. We have 2 logs. It would have been easy if we only had 1 log. If there was only a way to turn subtraction of logarithms into a single logarithm. I tricked you, because there is. There is a way, right? This is property of logarithm right here. This is the natural log of this becomes our numerator. Subtraction turns into division. And we get this. Okay? Yeah, let's all go home right now. Okay? So, now we have 1 log equal another. If 2 logs equal each other, their insides must equal. And what kind of equation does this become? This is our favorite from Math 930. This is a rational equation. Whoa! So we solve this by multiplying both sides by the LCD. Or you can think about it as cross multiplying, right? 6 divided by 1, cross multiply like this. Okay, so 1 times x is x, and then 6 times x plus 3. We need to solve for x, so we need to distribute that 6. Okay, so we get x equal to 6x plus 18. Oh, this is not bad. This is not bad at all. Actually, spoiler alert, we're going to have something happen in this problem. This one's going to be a chuckler. Okay, so subtract the x from both sides. Now we have 5x. Now we need to move the 18 over to the other side. All right. So we get negative 18 equals 5x. Divide both sides by 5. X is negative 18 fifths. So let's check our answer. All right, let's look at the left-hand side. The natural log of negative 18 fifths minus the... Oh no. What happened? Oh no. Now we'll do a attendance question after this one. Good reminder, Stella. We can't take the natural log of a negative number. You try typing this into your calculator, see if it equals the natural log of 6. You type this into your calculator's going to give you a very grumpy face. Okay? This does not exist. So this can't be a solution. Throw it in the trash can. Okay? It's in the trash can with Oscar the Grouch. There's no solution. There's no answer to this equation. Okay. If you have questions, now's a good time to ask questions. If you want attendance points for today, now's a good time to send in the attendance question. Attendance question is, give me the name. We sort of talked about TV a little bit, or a movie. Give me the name of a TV show or a movie. Okay? It doesn't have to be one you like. Could be one you hate. Just the name of any TV show or movie. Okay? Any questions on this while people are doing this? Those are essentially, that's everything for logarithmic equations, but we need to do the first chunk of exponential equations, which is going to be four problems. We'll do 4 problems, and if we have time for review, we'll review. So, the faster you guys answer the questions, the more time we'll have for review, maybe. You have 3 sections on your quiz today. That's a lot. Your exam is only 6 sections. Your quiz is covering this is probably not helping anyone. Okay, so here we go. Example 2. If I can find it. Solve. We did that. Wait. We can have the same extra credit question in 2 days. That's okay. Although, honestly, I don't remember giving it. Part A. 2 to the x minus 1 equals 2 to the 2x minus 4. This is going to sound a little familiar, okay? This is gonna jiggle your memory. We said that logarithms were one-to-one functions. Remember, one-to-one means it passes the horizontal line test. So if we had 2 logarithms equal to each other, their insides must be equal. So this is the same thing, right? 2 to the x is also 1-to-1. So if 2 exponentials equal each other, their insides are also equal. Okay? So we just say, hey, we got 2 exponential functions equal to each other. Their insides must be equal. That's the only way their equation can hold true. So we say that x minus 1 equals 2x minus 4. Well, I thought I stepped on my cat, but it was a hat. And I did not have a cat in the hat. All right. And again, y'all know how to solve this. We just subtract x from both sides, add a 4. Right? You get x equals 3. But then you get excited because you say, Jason, one of my favorite things about solving equations is that once I find my answer, I can plug my answer into the equation and check whether my answer is correct. You probably are thinking that right now. So let's do it. I don't want to disappoint you guys. Check our answer. How do we plug this in? Is 2 to the 3 minus 1 equal to 2 to the 2 times 3 minus 4? Is this true? Well, the left-hand side is 2 squared. The right-hand side becomes, well, this is 6 minus 4 is 2 squared. Is 2 squared equal to 2 squared? You know it is. 4 equals 4. Good. Good. Okay. This answer is brought to you by our robotic overlords. This is Robo answer. Okay. And that's how to do one kind of exponential equation. All right. There'll be some harder exponential equations that we'll talk about on Friday, but this is how to solve the ones we're going to do today. All right, 3 more. Part B. 8 to the x plus 2 equals 16 to the x plus 1. And you say, okay, great. If 2 exponential functions are equal to each other, then their insides have to be equal. But these aren't the same. They have a different base. So it's the same way. We're going to solve this the same way we solved the other one, but there's a little glitch. There's a little hurdle, okay? Well, I hope everyone's ready, because this is track and field now. And the hurdles are no problem. You just got to jump over them, okay? I'll teach you how to jump. It's because we recognize. Also, spoil a little hint, you could also use logarithms, but we're not going to use any logarithms until Friday. So these both have to do with 2's, right? So we're just going to write these in terms of 2. Isn't 8 just 2 cubed? Isn't 16 just 2 to the 4th? Yeah, so this is right here just 2 cubed. 8 is 2 cubed, it's the same thing. This is 2 to the 4th. And now we have the bases the same. So if we just simplify those exponents, snapping with our index finger, unless we want to be weird and snap with our middle finger. If we simplify the exponents, we can do exactly what we did in part A, and we will be good to go. So exponents are get multiplied by each other here. This is 2 to the 3 times x plus 2. This is 2 to the 4 times x plus 1. Remember, exponent with an exponent outside means multiply those exponents. And now, 2 to the x is a 1-to-1 function, right? 2 to the x is an exponential function. It looks like this. 1-to-1 means it passes the horizontal line test, which means that if these two things are equal, their insides must be equal. Were you lost on part A, Lane, or only B? Did I lose you in part A, or did I lose you in part B? Because essentially what we're doing right here is we're trying to turn this into a similar situation as part A. Okay. Also on Friday, we're going to talk about another method of solving equations like this that may or may not be easier depending on who you are. Okay. But the whole basic idea of solving these exponential equations is that if we have a situation like this, just like before with logarithms, if we had 2 logarithms equal to each other, their insides were the same. Here we have 2 exponentials, means their exponents have to be the same. We will be distributing the 3 and the 4. The reason I haven't distributed them yet, and this is a good question, is just because I didn't want to skip steps. I have a habit of skipping steps on occasion. Okay? So next up, we are going to say, okay, their exponents are the same. So, distribute that. That's 3x plus 6 equals, distribute that, 4x plus 4. And if we solve this equation, we're going to be good to go. All right. So subtract 3x from both sides. turns the 4x into a 1x. And then subtract 4 from both sides. We're going to get x is 2. And we're going to check our answer. So if we plug x equals 2 into the original equation, is it a true statement? Is 8 to the 2 plus 2th power equal to 16 to the 2 plus 1th power? I have no idea. Right? Is 8 to the 4th power equal to 16 cubed? I don't know what those numbers are, but I have a calculator. 8 to the 4th power is 4,096. 16 cubed is 4,096. There we go. So we know that's our right answer. Okay. We got 2 more of these. Okay, but before we do these last 2 problems, I really want to remind you of some properties of exponents. Okay? These are very important properties of exponents. If you forgot these properties, that's no problem. People forget math every day. Literally. We'll do some quick review. So, recall properties of exponents. Because they're going to be really important. So, right, if I have a to the n times a to the m, we add those exponents. Right? And just like before, if we had an exponent raised to an exponent, we multiply those exponents. Give these cute little numbers. And then 2 more really big ones. If we have a negative exponent, that means reciprocal. And if we have fractional exponents, that means radicals. So especially remember 3 and 4. These 3 and 4 ones, they're the ones that are going to get you. Okay? Number 3 and 4 is like you're riding on a bicycle and then some dog that comes up to your waist starts barking at you and chasing you. You're like, leave me alone, dog. I'm just on a bike. And he's like, get away from my property. Okay, that's number 3 and 4. So watch out for those. Okay. A dog chasing you on your bike, by the way, is really terrifying. Even if it's a friendly dog, because you don't know whether it's a friendly dog, right? All you see is a big spooky thing with teeth, making a lot of noise. Okay, so let's use these properties and solve the last 2 problems and then do baby review before the quiz. All right, so part C. Look at this. I'm actually just extending the piece of paper to give people a chance. Catch up if they need it. I'm actually learning. 2 to the 5x equals the square root of 2. So just like before, right? Just like before, we want to write this in terms of 2 to some power equals 2 to some power, because then the powers have to be the same. Okay? So how can we rewrite the right-hand side? What does our exponent become on the right-hand side? Okay? Someone gets a chance to live right now. Squaring both sides is not what I was going for, Lexi, but it is a 100% correct thing to do here. That is 100% correct. So yes, Lexi, that will work. We're not going to do it, but yes, you could do that. So yeah, the right-hand side is going to be a fraction as an exponent, specifically a fraction of 1/2. No, Lexi. There's a lot of ways to do it, a lot of different problems. And I didn't even think about that way. And it works. So being able to solve a problem from another point of view is very valuable. So I would even say good, Lexi. Okay. So the exponents are the same. Well, they're not. Well, they are. They have to be the same. They don't look the same. Let's set them equal to each other. 5x equals 1/2. Divide both sides by 5. X is 1/10. Okay. What happens if you do it Lexi's way, right? What happens if we square both sides? You don't have to write this right-hand column down. I'm just showing you. We square the left-hand side and square the right-hand side. Well, again, we have exponent raised to an exponent. That becomes 2 to the 10x. All right, you have to multiply them. 5x times 2 is 10x. The right-hand side just becomes 2. Remember, there's like a hidden 1 here. So then we get that 10x equals 1, or x is 1/10. All right, so 2 ways. All right, let's do the last problem. Last problem today, then we can maybe do baby review. Part D. 3. Wait. I forgot this one was in here. What about this one? A negative exponent means reciprocal, but this is not a negative exponent. This is a negative number. And we know what this left-hand side looks like. We could graph this left-hand side. This left-hand side looks, it's an exponential function, right? Graphing exponential functions was on your Thursday's quiz, which was a tough quiz, but scores were still higher than I expected. Let's see what the left-hand side looks like. All right, let's see what that left-hand side looks like. That left-hand side is 3. Whoa. 3 raised to the x plus 1 power. Stay in there. And remember when we talk about domain and range, right? What's the domain of this function? All the x's. All real numbers. What's the range of this function? Is only positive numbers. Sorry, Lane. I should not have laughed at that, but it seemed like a joke. The range is the outputs. The range of this function is only positive numbers. So how is a function that only becomes positive ever going to equal a negative? The answer is it won't. It won't. This is impossible. There's no exponent that you can raise this number to get negative 3. No solution. Okay. There's no answer here. So we showed how to solve logarithmic equations by isolating the logarithm and putting it in exponential form. We showed how to solve exponential equations when we can match the bases and then set the exponents equal to each other. On Friday, because we're doing review tomorrow, probably through Zoom, stay tuned for the Zoom link, and your exams on Thursday. So we're finishing the section on Friday. We've got juicy stuff on Friday. Here's what we got coming up for us on Friday. So we're going to use some logarithms to solve some of these ones. We're going to have to sometimes substitute to solve quadratic equations. That'll be good. And then we get to use radioactive decay and exponentials to solve some application problems. Friday's going to be a good section. Okay? But we have a little bit of time to talk about your quiz today. So your quiz is on some sections. Your quiz is on those 3 sections, right? Let me double check. Yeah, 6.3, 6.4, and 6.5. Okay, so 6.3, 6.4, 6.5. You should know how to do logarithmic functions. Okay. can you turn a logarithm from a logarithmic equation into exponential form? Oh, Jason, we did that today. What a great review. What great review, Jason. We already did that, right? The base of the logarithm becomes the base of the exponential. So we get 4 to the m equals q. We get a to the c equals b. 16 to the x equals y. X to the y equals 64. Okay. And then we can also use this to solve, oh my word, solve for x by converting the logarithmic equation to exponential form. We were literally doing this today too. Nice. Okay. This becomes 3 squared equals x. So x is 3 squared, which is 9. X is 9. Okay. 10 to what power equals 100 to the 8th? We could solve that. All right, so that's 6.3. 6.4 is graphs. How do you find the domain and range of a logarithm? How do you find the asymptote of a logarithm? For logarithms, remember, we can only take the logarithm of a positive number. Okay. So if I ask domain, it's just asking when is the inside positive. Okay. So to find the domain of number 6, for example, you say when is x plus 4 greater than 0? Solve that, put it in interval notation. For 7, domain. When is 1/2 minus x greater than 0? Because we need the inside of a logarithm to be positive. Okay. Lexi, you guys make me laugh. You guys make me chuckle. Okay. When domain for this, when is the inside positive? 2x plus 9 is greater than 0, and you have to solve those inequalities just like 930. It's all connected. Everything we're doing, it's like a beautiful tapestry or a tangled ball of yarn, depending on your brain. And then range of any logarithm. The range of literally every single function you see on the screen is the same. The range of any logarithm is all real numbers, just like the domain of every exponential is all real numbers. Domain of exponential is the range of the logarithm because they're inverse functions, right? Well, we talked about inverse functions earlier this year. Domain of a function is the range of its inverse. The range of the function is the domain of the inverse. Wow, it's all tied together. And there's 2 ways to find the asymptote, by the way. But one of the quick ways is remember the asymptote is always just at the edge of the domain. So here I find the domain is negative infinity to positive 5. Sorry, positive 5 to positive infinity. So the asymptote's just at x equals 5. It's a vertical asymptote. Right? Here the domain is negative infinity to positive 3. So the asymptote's at positive 3. X equals positive 3. Okay. Finding intercepts. Remember what intercepts are. When is x equals 0, when is y equal to 0. And then logarithmic properties. You just have to really remember. Surely they must be in here somewhere. Well, looks like they're all separated, right? All of these properties. If you have an exponent on the inside, like multiplying it by a number on the outside. If you have division on the inside, it's like subtraction of the logarithms. You're going to be asked to expand logarithms, right? Which may take multiple steps. And this one right here, log of 7x plus log of 2y, and then you can split up each one of those one more time. Okay. Condensing. For this one, right? They're all added, which means they all turn into multiplication. This becomes the natural log of 7xy. Condense them all as much as you can. And remember to condense them, right? You have to deal with the coefficient in front first. And then they could get messier. Just do it one step at a time. First, You have the numerator subtracted by the log of the denominator. Then split up the numerator again. Then do those exponents. And then they get harder as well. But those are the basics. Okay. So just about quiz time. Good luck. Ask me any questions if you have them on Discord. Maybe I'll answer them. Maybe I'll say, oh, I can't answer that. But you don't lose anything by asking, so may as well ask, right? Good luck. We'll have a review tomorrow. Stay tuned for the Zoom invite. Your exam's on Thursday. Your final is next week in 9 days. And then you will sadly be done with this class. All right. Bye-bye.